Okay, cool. Now we're recording. Okay, so in this lesson, you'll think about equivalent expressions. Guys, quiet, please. Use an area model to determine that two expressions are equivalent. Find new ways to write expressions. As you work with your team or table group, use the following questions to help you focus your discussion. How can we be sure they're equivalent? How would this look in a diagram? Why is this representation convincing? All right, so let's look at these two. Now, this is a classic example of students messing up. And this is actually one of my biggest pet peeves. Students will think these are the same, and they're not. Not always. So let me give you a good example why these are not the same. So this is not, actually, I'll just do my stylus here. So this is not necessarily true. And I'll give you a good example. It all comes back to PEMDAS, right? Yeah, so Jack, so the left side, what would the left side be, Jack, if you were to work that out?
You'd be adding x plus y, so it's like 1 plus 1, you get 2 squared.
No, but the example I just gave.
Oh, it'd be 7 squared.
Right, which is 49. The other side, what do you have? Yeah, clearly those are not the same. So because of PEMDAS, you can't say those are the same. Now, you could make them the same if you let x be 0 or y be 0. It could work. Sorry, this new Zoom update's kind of annoying. Let me click somewhere. There we go. It could work if x or y or both equals 0. Then it could work, but you can't really assume that. So Jonah is actually incorrect. Graham is obviously correct. So let's figure out how he can prove that. So help Graham finds many ways possible to convince Jonah that he is incorrect. So yeah, that's one way, right? So I just kind of did that for you guys, right? I kind of did part A without realizing it. So one way is just to plug in numbers. That's one way you can prove it. Now, are there any values of x which this would work? The answer is yes. And I just did that for you guys over here, right? For part B. But you still need 0 for one of them. Yeah, because if you do 1 and 1, you get 4 on the left side, but 2 on the right side. Yeah, so you need 0, at least 1. Now, what's really going on here? Let me actually do this in green so it stands out. What's really happening is you have to FOIL the left side, right? So give me a sec here. So if you FOIL the left side, so algebraically, oh geez, oh goodness, this new Zoom thing's driving me nuts. Okay, here we go. Okay, algebraically, you have to do x plus y times x plus y, which winds up becoming this, which does not equal x squared plus y squared. So that's really what's happening. If you FOIL x plus y, you get an expression that's different than this. Now, what happens if x squared and y squared cancel, right? Ultimately, what happens is that these would cancel, leaving me with just what? And let me erase some of the stuff here. Ultimately, when x squares and y squares cancel, well, how does the equation look now? What is it again? Exactly, right. Exactly. So then 2xy equals 0, or x equals 0, or y equals 0, in order to make that work. That's why it can work if x or y is 0. And that's the only time that would ever work. So that's what's happening there. So very important that we don't make that mistake, because that some people think they could distribute the square. You cannot distribute the square. That's just something you cannot do. Only time you could do that, you can't distribute the square operator when there is a plus or minus inside. I know it's a lot of writing, guys, but I want to make sure you guys get this. You can't distribute the square operator when there is a plus or minus inside the parentheses. You can't do that. One could do though. There is a time when you could. Do you guys know when you could? What if I replace the plus with a time sign? You can distribute the square operator when there is a times or divide. For example, in that case, that's okay, right? Because you could write it as 3 squared times 4 squared, which still gets you the same thing if you follow PEMDAS. So that'd be 9 times 16, which is 144. Or you do 12 squared, which also equals 144. So in this case, you can't if there's a times inside or division. But you can't when there's a plus. So that just comes back to properties of exponents, right? We've talked about in the past. Just want to make sure we're clear on that, because I don't want these mistakes to happen 3-4 months from now. Or if I teach you pre-calculus next year, I don't want that to happen, right? So questions on that one? I know I kind of went on the deep end with that one. We're good? All right, let's keep moving, guys. So hold on. Need updates. And it's gonna take a little getting used to here. All right, let's look at 314. And we'll do some practice problems on the next page. Do you think an area model can help rewrite expressions by multiplication? Totally, 100% it can. So see what they did here. They did a box, and I think you guys have my students before, and I've probably done this with factoring with you guys. Notice we're doing 3x times 2x, 6x squared. 2x times 1 is 2x. 3x times -3 is -9x. 1 times -3 is -3. And then when you combine it all, you have 6x squared, -9x, plus 2x minus 3, 6x squared, -7x minus 3. There you go. So yeah, the answer is yes, you can. You can use an area model to help you with that. And also to help you factor as well. So let's do it again for B and C, and then we're going to try it on groups in the next page. Let's look at B. So we'll set it up. That's supposed to be an arrow. That's a terrible looking arrow. There we go. Okay. Okay, we'll set it up here. Now let's switch colors again. Let's go to light blue. Okay. So I'm going to put 5K and -3. My K's look terrible. 2K and -1. Okay. So what's going to happen? What's 5K times 10K, guys? Yeah. What's 5K times -1? Yeah, -5K. What's 2K times -3? And finally, -3 times -1. Do we have like terms in this box? We have 2 like terms, which are what? And how, when you combine them, what do you get? Perfect. There you go. So if you need an organized approach, you could do this. I mean, once you do enough of these, like you could just do it kind of in your head. Like you kind of figure, well, yeah, obviously 5K and 2K is 10K squared, -3, -1 is +3. The middle ones, you gotta be careful. 5K, -1 is -5K, -3 and 2K is -6K. That gets to be -11K. But when you start dealing with like larger powers and other weird stuff, sometimes it's good to write it out. But the little table or whatever area model could help with that. We do the same thing with part C, but now this is factoring. So this is FOIL, right? What does FOIL stand for? It's an acronym. Does anyone know FOIL?
Outside, inside, last.
Right, first, outside, inside, last. So, well, first, outside, inside, last. Exactly, right. Factoring is the opposite of FOIL. So sometimes you guys get the terms mixed up, but part C is not foiling. That's the opposite. It's already foiled for you. You gotta undo the foil. So let's draw another table. Okay. So this is a little tricky, but I'm going to put x squared in here and -4 in here. I'm going to do a little diamond because I just like to. It's just my own personal preference. And I always put a times c up here and b down below. Okay, remember, generally this is ax squared plus bx plus c. A is the leading coefficient, b is the middle coefficient, c is the constant. What's the leading coefficient for this expression here? You don't see one, what do you say? And the middle one is -3. The last one, of course, is -4. So if I did a times c, which is 1 times -4, boom, -4. If b, boom, -3. What two numbers multiply -4 and 1 exactly? So what I'm going to do is I'm going to put -4x and positive x. So this is called splitting the middle term. Because the middle term is now split into two other parts, right? Now, oh, come on, here we go. What two things have multiplied x squared? What can I put here and here? X and x, right? That's not so hard, right? What would you multiply to x to get to x? What would you put over here? X times what gets you x? 1. Let's look over here. X times what gets you -4x? And just to check, what's -4 times 1? -4. So now we have a factor. X minus 4, x plus 1. This technique is rock solid. You get more complex factoring where the leading coefficient is not. That's like a number like 2 or 3 or whatever. It's a really great technique that I strongly encourage you guys to do. So that's how I've always done. How I was always taught. I've taught this way for 19 years. This kind of factoring. So I'm not going to go away from it now. And CPM happens to do it the same way, which is kind of refreshing. So yeah. So does that make sense? What I just did? Yeah, we're good. All right. So now you're going to practice, right? Because we got to practice these skills. So let me clear. And let's see what the next page is all about. So next page is asking to rewrite. So either you're going to FOIL or factor. So in the case of A and D, in the case of A and D, you're going to factor. In the case of C, and I'm going to kind of put little quotation marks. It's not technically FOIL because you have 6 terms for B and E. And then here, this will be FOIL, then combine like terms. So let me set up actually E for you guys, because E is kind of a funny one, as well as B. And then I'll let you guys get to work and look at the answers in a few minutes. So what I would do for something like E, I kind of write like this. P squared, 3p, and 9, 2p, and -1. So it's kind of like FOIL, but not exactly, because you're not necessarily doing 4 terms, you're doing 6 terms. So it's kind of like FOIL. Anyway, so let's work on these 6. This should be pretty straightforward. I'll pause the recording and recording. Okay. All right, so here are the answers for 15. So A and B were factoring, of course, right? B, E were kind of like FOIL, they're a little bigger. And C and F for that. Questions at all? Do you guys need more time? You guys, I was. We'll try to understand.
It's like 42 was the 2 as the coefficient. I don't really know.
Which part? Yeah, let's talk about A. Yeah. Let's talk about A. Okay, so for A, oh yeah, that's a tricky one. Let me do that with you guys. A is kind of tricky. Actually, thank you for bringing that up, Hunter. What was that? Sorry. That's just FOIL. Okay, guys. So here we go. So what I would do, guys, quiet, please. A times C and B. So your A is 2, your B is 5, and your C is 2. So A times C is 4 and B is 5. Oh boy. Wait, yeah, no, we're okay. We're okay. So what two numbers multiply 4 and add 5? 1 and 4, exactly. So then what you do next is this. You make a table. You put 2x squared here, 2 here, and you put x and 4x. So what this does, this diamond, if you call it that, I guess, it enables you to split the 5x. So you split the 5x that. Now what you do is you look at each row and each column. What can you pull out of the first column? A 2x, right? And then what do you multiply 2x to get 2x squared? Yes. And then what do you multiply to x? To get x out here. Exactly, right. Now you're almost there. What do you multiply to 2x to get 4x? You go 2x. And then as the final check, is 1 times 2, 2? Yeah. 1 time on the outer edges, 1 times 2. Yeah. 2. So you got 2x plus 1 times x plus 2. So that's how that works. Oh my god. Let's do F, guys. Okay, guys, quiet, please. Let's work through F. By the way, for D, you can do something similar. You don't see a B value for part D, right? There's no middle term. So what do you assume the coefficient is for X for D? For part D, like you don't see a middle term, you don't see an X. It's 0, exactly, right. So if you do the diamond, you put a 0 here, and oh boy, that's a really big number. That's negative 196, which would be negative 14 and 14. But the bottom line is, you know, it's the difference of 2 squares. So you could just always just go straight to the factor form too. 2x minus 7, 2x plus 7. But if you want to do the diamond, you could, where you put 4x squared, negative 49, and then blah, 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 negative 14x, 14x. And you kind of work it out. But let's do F, though. Let's do F. So you want to FOIL, right? Let's look at F. 4, negative x, x squared, and 1. 4x squared, negative x cubed, 4, and negative x. So now you got, guys, quiet please, negative x cubed plus 4x squared, negative x plus 4, plus 3x minus 5. Okay, so again, just be very methodical about it, right? Okay, I got 4 negative x, I got x squared and 1. Awesome. 4 times x squared, 4x squared, 4 times, sorry, negative x times x squared, negative x cubed. 4 times 1, 4. Negative x times 1, negative x. Combine like terms. What are my like terms here? Let's see. My like term is going to be 4x, negative x, and 3x. And of course, 4, negative 5. I lied, 4x squared. My bad. I lied. That's 4x squared. My apologies. Negative x and 3x, and 4, negative 5. So you have negative x cubed plus 4x squared, positive 2x, and negative 1. Because you have two pairs of like terms. Negative x is one pair, 4 negative 5 is another pair, and you got it. Now, if you wanted to check your work, you could. You could check your work. It's actually not that hard to check your work. What you could do is make up a number for x. Like let x equal 0. Let x equal 0. If I plug in 0 for x, what do you get? You get 4 times 1 plus 0 minus 5. 4 plus negative 5 is negative 1. What if I plug in 0 to the final answer? Do I get negative 1? Yeah. It should be the same if you plug in correct. It's just an easy number, right? So that's the technique you use to see if you did it right. If you have confidence, like on a test or a quiz, like, hey, I don't know if I did this right. You know, well, plug in the numbers. The original and the final form. They should be the same. So, okay. Let's keep on moving here. All right, 316. Decide whether the following expression can be represented with a model and rewrite each expression. More the same thing. Now, one thing I'm going to caution you guys. This is a mistake that a lot of students make sometimes. I'll do part A, then I'll have you guys do part B. So some students will do this. don't do this, by the way. So don't write this down. Just put your pencil down for a sec. Some people will say, oh, P distributes, right? So it distributes here and distributes here. That is so bad. Because some people say P squared plus 3P, and then they'll say times 2P squared minus P. But here's the problem. Then that requires P squared. That requires an extra P to do that. You don't do that. You choose which one you want to distribute it to. You can distribute it to the first one if you want, or distribute it to the second one if you want. But you can't do it. You can't do it to both. And I don't know why. I don't know what's going on here. Okay. This new Zoom thing's driving me nuts. Yeah, so, or you do that one. Because, for example, what if I have 2 times 3 times 4? How'd you work that out? You did 2 times 3 times 4. What would you get, guys? What's 2 times 3?
6.
Times 4, 24. Or you could have done this. Multiply the 2 and 4 together, and still get 24. But do you multiply 2 to both 3 and 4? No. You choose which one, right? Is that LA speaker? Yeah. So anyway, you don't distribute to both. Just choose one. So say I do the first one, and then you FOIL after that. So you do P squared, 3P, 2P, negative 1. There we go. Okay, so all's good. I knew it was Elliot. Called it. All right. Anyway, all done.
No question.
Oh, fire away. Yeah.
Is it? Do I do 4 different ones or is it?
No, all one, just one equation. Yeah. Okay. All right. So why don't you guys try part B really quickly? See what you guys get. Now in this case, you'll distribute. Then combine like terms. Okay. So distribute that x is at x plus 1, and then combine like terms. That's an arrow, by the way. Crappy looking arrow. There we go. Okay. So let's work that out really quickly. Should only take like less than a minute to do. Right? Pretty easy, right? Not too hard. So it's simplifying. That's what we're doing. We're simplifying these expressions. Questions about 316? No? Okay. Let's well wait, Pierre's still copying. Let's see who's sharing. Okay. Are you guys typing something in the calculator?
No.
All right. Let's keep moving. Okay. So for this one here, what are we going to do? We are going to fill out the missing part. Shouldn't be that hard. So what I want you guys to do is hold on a sec. Let me do part A because I'm a little confused how they're doing this. This seems a little funny to me. How they're writing this out. Yeah, give me 1 sec here. I think they want a y here. Nope. Okay, give me 1 sec. Yeah, I think they want a y here. So this has to be 3y. And that's another y. That just seems weird to me. I don't like the way this is written. It seems really weird to me. Part A seems, yeah, I don't get what's going on with part A. Actually, let's just cross out part A. Part A just seems really weird to me. B seems a little more legitimate. I like B better. What do you think would go up here, guys? And actually, let me do it down here, just to be consistent. Here we go. Okay, so let's fill out those little ovals, right? Those little circles. What do you think is going to go here to here? Let's look at the lower left and the one on the right, the lower right. What do you think is going to go in each of those circles to make that 8x? What do you guys think? Well, what thing I put in the lower left? I put x, yeah, because x can be factored out of the first column anyway. Then what would I put in the lower right box circle? 8, perfect. Okay. So what goes over here now? 24. And then what do you think goes over here? X. And so then this would be 3x. So it comes x squared plus 11x plus 24. That's part B. Once you guys try C and D now in your table groups, I'll walk around, make sure you guys are doing okay. So very similar to what I did in part B. You kind of figure out what to go. So what you'll need to do is you need to figure out what goes here, here, and here, and then the box. Here, here, and here, and what goes in the boxes. So let's try those out. Okay. Okay. So I want to share what they have for part C. What would you guys put? No, in the lower left red circle. What did you guys put?
2x.
Yeah, totally. What would you put in the lower right circle? Good. Okay. So now, let's think about this. What would you put in this box right here? 12y. Good. So then what do you think goes in this red circle? 5x. Then you get 10x squared. And you get 25x. Okay, cool. And then down here, there should be an x. And this should be, hold on a sec. If you have a 12, seems kind of open-ended, actually, to be honest with you. You could put a 3 and a 4, I think. But is that the only way you can do it? No. Could have also done this, right? You could have done like 2 and 6. Either 1 and 12. Or it could have done negatives. Yeah, so there's actually infinite possibilities for this one. Not infinite, sorry. Multiple possibilities. I'll go back to 3 and 4. there are multiple possibilities for that one. So, because you didn't have quite enough information for that one there. Okay. I'm going to skip one of the examples just in the interest of time. Let's look at 319. So this is called difference of squares. What this means. Okay, the Zoom thing's driving me nuts. What's going on here? Let's try again. All right. Okay. So difference of squares is when you have something like this here. So basically these have to be perfect squares. If that's the case, you can break it up like you see on the right side. So let's look at Roman number 1.
What's the square of a square? Like what times what is a square? A and x. What's the square of 4b squared? Like what and what multiplies 4b squared? 2b and 2b. Those are identical, right? A, 2b, 2b.
But because there's a minus in the middle, so you need to have a minus in the middle for this to work. A minus 2b, A plus 2b. So this is a matter of just recognition. Just recognize the pattern and factor. If difference of 2 squares. Right? Just recognize the pattern and factor if difference of 2 squares. Now, look at 2.
2 is not a perfect square, unfortunately. 16 is, because 2 first square down. But usually what you always want to do is, can you factor something out here? You factor out 2.
Is 8 a perfect square? No, you can force the issue and make it a radical, but why? It's not necessary. So you stop there. So you stop there. Let's look at, let me switch colors. Let's look at 3. I'll rewrite like this. And let me erase that. Okay. Let's look at this one. Is this a perfect square? Why is a perfect square? You could write it as y squared minus x and y squared plus x.
Because y squared and y squared gets you y4, x and x gets you x. So you can write it that way.
But this one can't be factored. There's no minus sign. There's no such thing as sum of 2 squares.
It just can't be factored. Just leave it alone.
You have to have a minus. Very important for this to work. One thing that I think you guys might appreciate, factoring flowchart. Yeah. Maybe I'll have this ready for you guys next week. Let me clear my screen for a sec. Yeah, you guys might like this if you get stuck in factoring.
Ask them how many terms you have, 2, 3, or 4 terms. Are there common factors? Pull them out. Then go down here. Does it give you 2 squares? Yes. Done. If not, then you're done. Common factors, 3 terms. Take them out. Is it first, last, and perfect squares? We're going to talk about that in the next example. You factor. If not, leave coefficient 1. No, then you have to use that grouping or the box thing, or just do the diamond here. You have 4 terms, just factor groupings, another type of factor.
So this might be a good way to just kind of keep things organized. I could actually create this when I taught Algebra 1 about 18 years ago. Still use it today. So one of the good things I did in my first year teaching. So anyway, let's go back to the last. So let's skip 320 in interest of time. And let's just look at 321. And then you guys can get head start on homework. Also, because I want to prepare your next set of notes and give it to you guys today, since I won't be here tomorrow. Just so you guys have them, the next set of notes. So perfect square trinomials. This is a very special case. Let's look at part B first.
What two numbers multiply 9 after -6? -3, -3, those are identical.
Right? So you could just say it's x minus 3 times x minus 3, or x minus 3 squared. This looks just like the
Computing square process, right? Remember we had to complete square to make it look like something nice and tidy like that.
it's actually kind of the same thing. So how can you tell? How can you tell it's perfect square trinomial? The first term and the last term are perfect squares. First term, last term are perfect squares. Also, the square root of the first and last terms, the square of first and last terms, multiply sorry, let me take it back. Also double I'm messing this one up. Sorry, guys. The square of first after multiplying by 2. Kind of weird.
I know, kind of weird. What's the square of 9, guys? 3. The square of x squared is x.
So what's x times 3? 3x. Then double it. But of course, you got to put a negative in the middle. So you get negative 6x. So that will work if you have the situation here. So actually, I think I wrote better my flow chart. I didn't really articulate that very well. My apologies. Yeah, here we go. I think I articulate much better down here.
So notice I see like a little asterisk, right? The first last two perfect squares, back it like this. Make sure the middle term is twice the product. That's what I'm going to say. It's the product of the square versus the first last one. I meant to say that. So yeah, we had x squared and 9. The square root is x and 3.
Twice that product is 6x. That's what I meant to say. So this one here for part A would be a plus b times a plus b, or a plus b squared. Yep. So take a look at C now. It looks nasty, right?
But think about it. Is 9 a perfect square? It's 5 perfect square. What square of each of those? 3x and 5y.
Okay. So you have 3x and 5y. 3x and 5y. Now, as a final check, what's the product of 3x and 5y? You multiply those together. What's 3x times 5y? And double it becomes, so you know it works. If it was some other weird number, like say, I don't know, like 24, then forget about it. You can't do it. But since it's 30, yeah. And then you can make it more compact like that. Okay, last one, part D. This one's kind of weird. But what if I replaced that with x and replaced that with x? Does that factor like the other ones?
X squared minus x plus 25, or x squared is 25 perfect squares. Yeah. It was x minus 5 times x minus 5, right?
However, we don't have x. We have a minus 7. So what you do is you do the same exact thing. I'm gonna do these brackets here. You do the same exact thing. A plus 7, A plus 7, minus 5, minus 5. Or it becomes A plus 2 times A plus 2, or A plus 2 squared. And there you go. So that's a little tricky, but you have to recognize the pattern, right? Like, oh yeah, those are perfect squares. But instead of a single variable, we have A plus 7, but just make it think like a single variable and you'll be fine. Okay. So we're going to stop there. What time did we get out? 25? Okay, so yeah. Pretty long lesson. Thank you for being patient. And we had the earthquake thing that kind of threw us into a little loop. So no earthquake, we're okay. So homework's down here. Extra problems, you want to try them. It's already attached. If you guys want to head start, go ahead. If you want to wait, that's fine. Let me finish preparing the next set of notes. I'm going to try to get the next 5 minutes and hand it out to you guys. If not, don't, you're still have to hand it out to you guys. Let me stop the recording.